How do forces affect the motion of an object? And how can a force diagram be related to a kinematic representation of a motion, like a dot diagram or a motion graph? Well, I'm Mr. H, and I have some answers for you. Forces are pushes or pulls that act upon an object as a result of its interaction with its surroundings. We represent forces by force diagrams. Each arrow represents a force. The length of the arrow is representative of the strength of the force, and the direction goes in the direction of the force. There is no limit on the number of forces you can place on a force diagram. When viewing a force diagram, it's important to distinguish between balanced and unbalanced forces. When oppositely directed forces are of equal strength, we say the forces are balanced. Balanced forces cause objects to keep on doing what they're doing. If at rest, they remain at rest, and if in motion, they continue in motion with the same speed and direction. Balanced forces never cause objects to accelerate. When you see this or that, you know the object has a constant velocity. It could be at rest and staying at rest, as represented by these kinematic representations. Or it could be moving and continuing in motion with unchanging velocity, as represented by these representations. Without ever stating it, I've been describing Newton's first law of motion. Objects at rest stay at rest, and objects in motion continue in motion with the same speed and direction, provided all of the forces are balanced. But do be careful, because not everybody believes in Newton's first law of motion. Let me explain. Here's a force diagram with an up and down force. Can this object be moving to the right? Or what about this force diagram with equal strength forces in all directions? Can this object be moving to the right? The answer is yes. Each of these objects could be moving to the right or to the left. You can't tell which direction an object is moving from the forces that act upon it. You can only tell how it is moving. And when you see a balance of forces on a moving object, you know it will continue moving with a constant speed. There doesn't need to be a force to the right for it to move to the right. Once an object is in motion, it will continue in motion with the same speed and direction as long as the forces are balanced. Unbalanced forces cause a change in motion, an acceleration. These diagrams show unbalanced forces. Unbalanced forces occur when oppositely directed forces are of unequal strength. We say there's an unbalanced force or a net force. When there is an unbalanced force, there is an acceleration in the same direction as the unbalanced or net force. So object 1 accelerates to the right, object 2 to the left, object 3 upwards, and object 4 accelerates downwards. But do be careful, because to accelerate to the left doesn't mean to move to the left. Let me explain. Here's two dot diagrams, one for an object moving to the right and one for an object moving to the left. But both objects are accelerating to the right. When an object is moving to the left and getting slower, we describe its acceleration as being directed to the right. Both of these dot diagrams are consistent with more force to the right than to the left, as represented by the force diagrams. So these force diagrams are representative of a rightward acceleration and can be represented by any of these kinematic descriptions, since each description represents a rightward acceleration. Here's two more force diagrams. Notice that there is more force to the left than to the right. With an unbalanced force to the left, the object accelerates to the left. It could be moving to the left and speeding up, as represented by this dot diagram and these graphs. But it could also be moving to the right and slowing down. In each case, the object has a leftward acceleration. A leftward unbalanced force is always going to cause a leftward acceleration. Without stating it, I've been describing a portion of Newton's second law of motion. An unbalanced or net force causes an object to accelerate in the same direction as the net force. Once more, you need to be careful. Unbalanced forces don't cause objects to move in a given direction. Rather, they cause objects to accelerate in a given direction. Unbalanced forces cause objects to speed up or slow down. If there's more force against the motion than with the motion, the object slows down. But if there's more force with the motion than against the motion, the object will speed up. We can repeat these same ideas for vertical motion. When there's more down force than up force, the object accelerates downwards. It could be moving up and getting slower, or it could be moving down and getting faster. When there's more up force than down force, the object accelerates upwards. Just like horizontal situations, when there's an unbalanced force, the object always accelerates in the same direction as that unbalanced force. The relation between force and motion can be one of the most difficult concepts to grasp, and you need to give it some patient practice. You'll find some pretty awesome interactive exercises on our website that will help you to make sure that you got this. You'll find links to them in the description section of this video, so give one of them a try. Hey, I'm Mr. H, and thank you for watching.